next named reaction we are going to be learning about is Kolbe's reaction. Now, do not confuse this with Kolbe's electrolysis. That's an entirely different reaction that you'll learn in the last chapter, I think. This one, on the other hand, is actually in the chapter Alcohols, Phenols, and Ethers. So, basically, first to start with, phenoxide ion and phenol. These are actually two different things. Phenol is a benzene ring with an OH group. Phenoxide, on the other hand, with an O minus. Okay, so what happens technically? OH and O minus, and the phenoxide ion is actually highly reactive. So this is formed by the treatment of phenol with NaOH. So the phenoxide ion is so reactive, and because it's highly reactive in nature, it can also react with a weak electrophile like carbon dioxide. So what happens in this reaction is sodium phenoxide is heated with carbon dioxide at 400 degrees Kelvin, 400 Kelvin and 4 to 7 atmospheric pressure. This leads to the formation of sodium salicylate. Okay, instead of telling you all of this, let us write that down. So you have sodium phenoxide reacts with carbon dioxide in 400 Kelvin and 4 to 7 atmospheric pressure to lead to the formation, or rather it's heated, right? So to lead to the formation of sodium salicylate. This sodium salicylate is acidified, or on acidification gives rise to salicylic acid. So this is the basic idea behind Kolbe's reaction. So you have a sodium phenoxide ion which is formed by reaction of phenol with sodium hydroxide, and since sodium phenoxide is very reactive in nature, it can react with a weak electrophile like carbon dioxide, and this is at 400 Kelvin and 4 to 7 atmospheric pressure forms sodium salicylate, which on acidification leads to the formation of salicylic acid. So let's write the reaction. So we have phenol, so benzene with an OH group. This reacts with NaOH to form sodium phenoxide, O minus Na plus, and this reacts with carbon dioxide at 400 Kelvin and 4 to 7 atmosphere pressure. Pressure, and this forms so basically OCOONA. Okay, this is called as phenyl sodium carbonate, and this on rearrangement gives OH on and to it OCOONA, and this is sodium salicylate, and this on reaction with dilute HCl, so it's acidified, I'll write it down, leads to the loss of NaCl. Okay, and okay, and forms salicylic acid. Oh, I'm sorry. So that's Kolbe's reaction. So if phenol reacts with sodium hydroxide to form sodium phenoxide, which on reaction with carbon dioxide at 400 Kelvin and 47 atmospheric pressure forms phenyl sodium carbonate. This phenyl sodium carbonate undergoes rearrangement to give us an ortho product of sodium salicylate, which on acidification forms salicylic acid. So here you have the ortho product being formed. Actually, the para product also forms to a certain extent, but at temperatures above 410 Kelvin, we have the para product being formed as the major product. So the OH and the COH will be at the para position. So that becomes the para product. And one important thing over here you need to remember, I mean, you could wonder why phenoxide reacts with carbon dioxide, which is a weak electrophile. That's because sodium phenoxide ion is highly reactive in nature, and that's why it reacts with carbon dioxide. But this is the basic reaction behind Kolbe's reaction. Do not confuse it with Kolbe's electrolysis. With that, we're done with this. In the next video, we'll be talking about Riemann-Tiemann reaction.